So your boss in a meeting came up with a new requirement where he wants you to deploy an application, and he said, "Hi, host an application which will be used as a simple reporting API service for our customer data, and let me know once it's done." And you were fine with that. You said, "Sure boss, I will work on that as soon as possible and will update you once the service is up and running." So you went ahead and wrote your API code, and your first thought was to deploy it on an EC2 instance because you have been doing it for a long time while hosting applications. And to host it on EC2, you had to go through these steps. So you had to choose the VPC, then you had to choose the AMI for the purpose, choose the right processing unit, choose subnets to maintain high availability, then choose the storage, and then attach the security group, and ultimately you had to deploy the code that you have. Then you took a pause and you realized that you still have a lot to do. So you went ahead and created the launch templates. You then created the auto scaling groups. Then for the load balancers, you created the ALB, and then for the storage, you created the deployment for the database. And finally, you succeeded in creating the deployment. Finally, you came up to your boss and you were happy to share this information. "Hi boss, we are done. I have hosted the application and we can make use of it." And you said you had deployed it with an EC2 instance with auto scaling. Your boss went ahead and rejected this, saying, "This is not feasible. It's just a simple report generator. Do you want us to spend this amount of time in future as well, managing these servers for a single service, which will be used in short spans?" There was nothing wrong with the product and the API service. The users would still be able to make use of the service, but the thing that would get affected is the efficiency of the platform and the infrastructure maintenance. The amount of time that we would spend in maintaining the instances and the deployments for a small or simple one-directional API service would be fairly laborious, which would not be a feasible option in the longer run due to the operational overheads. And that's where AWS Lambda came into the picture. So you went ahead and switched things around by moving on with the serverless approach. You started off by deploying your code, which is an API service written in Python, by creating a Lambda function, by providing the required memory for its processing. For the report files, you attached an Amazon S3 bucket where you planned to store your report files. For table entries and the inventory and the user data, you moved ahead and attached a DynamoDB, which is a serverless NoSQL database. And for your API trigger point, you went with the reverse proxy service API gateway, which we will be discussing in the upcoming sessions as well. For now, just remember that API gateway is a service provided by AWS, which helps us to create an entry point for the backend services and which sits between your clients and the services you host. So now the users are happy and they are able to connect to the API, and your boss surely appreciates the design. But you might ask me, what did we achieve by switching our application hosting to AWS Lambda, which was already hosted on EC2 instances, and why we moved to a serverless architecture? That is the reason we are here. So let's see what we can achieve with EC2 and what makes it different than Lambda. So we mostly recommend using EC2 instances if you want to host a complex multi-purpose website, or if you are hosting and testing with multi-purpose processing powers for various use cases, or when you need consistent high performance computing, or when you have the need to create pre-configured images or customized AMIs. On the other hand, Lambda is a very short and simple multi-utility serverless service, but without a doubt, it's a very powerful one as well. So when we compare it with EC2, in AWS Lambda, we don't have to launch any virtual machines to host our code, and that would be the most basic difference, as its rightful name comes from being a serverless computing powerhouse. But for now, let's talk about some of the pointers here as well. If we want to host short compute time modules, or if we want to provide a function as a service using AWS Lambda functions, of course, or if we want to provide a compute power for simple task automation, or if we want to have a provision for real-time log analysis, and henceforth. So these are a few differences that make AWS Lambda very useful when it comes to compute optimization. So as per AWS Lambda lets you run code without provisioning or managing service, and you pay only for the compute time you consume. So here you don't have the need to launch virtual machines and keep them running all the time, and you pay for the compute time only. I hope you remember the previous session we had. We already discussed about serverless and why we associate the use case with this term called serverless. If you haven't, then I would request you to please check the video out. Link is in the I button above on the top right corner. As I've already mentioned before, with serverless, you need to bring your code or application, and you don't have to worry about the application hosting, and you will be provided with the computational resources that you need to create a productive application with obviously a high availability and the power that it needs to serve its consumers' requests. So when I say AWS Lambda lets you run code without provisioning or managing servers, and you pay only for the compute time you consume, what it means is that you can run code for virtually any type of application or backend service, and you don't need any administration of these servers. You have to just write the code that you want on the Lambda editor, or if you want, you can upload your code to AWS Lambda, and Lambda will take care of everything required, or what we rightly call as resource provisioning, to run and scale the code that you have, and in turn it will also provide high availability. And the best part about this is that AWS Lambda, you can set up your code to automatically trigger from other AWS services or call it directly from any mobile or web application. That gives you the power to get the results from anywhere you want. So there are a few important features of AWS Lambda that we have to discuss. First off is no servers to manage, and AWS Lambda automatically runs your code without requiring you to provision or manage servers. I think this is quite evident now that you don't need to create or provision or manage any servers to run your code, and you can just post your code on the AWS Lambda and run them using any trigger point. The second one is continuous scaling. So for continuous scaling, AWS Lambda automatically scales your applications by running code in response to the trigger. So let's suppose you have a lot of users using your service, and in that case your code can run in parallel and each trigger will be processed individually. That's a very big thing. The trigger means an API call or execution, like for example you send a GET request or a POST request to perform a call using an HTTP request, and the scaling will be done automatically based on the size of the workload. The third one is sub-second metering. So sub-second metering means like charging you for a unit of work or operation. So with AWS Lambda, you are charged for every 100 millisecond your code executes and the number of times your code is triggered. So you are charged for the unit of work that you perform. The last one is consistent performance. So whenever we host the service, we try and estimate the amount of processing power that it might need, isn't it? And based on which we provide the resource. Here with AWS Lambda, you can optimize your code execution time by choosing the right memory size for your function. And you also get the option for provision concurrency to keep the response time within double-digit milliseconds. So now let's check the visualization here. So here it's a very simplified way to look at the workflow with AWS Lambda. First off, you write the code that can be your service API, or you can upload it to AWS Lambda, and then you create a trigger point that kicks off the Lambda code that you have and the code execution using a static website that is hosted on the AWS S3 or any trigger point that you have, which in turn triggers the function that's hosted or written into using AWS Lambda, and upon execution you get the result back and you are charged only for the compute time, or what we can also phrase it as the duration of time it takes to execute the code. So you write the code, upload it to Lambda, then execute your code with a trigger point and get charged for the compute time.